Look out your window at the city skyline. Every glowing window, every street lamp is powered by a vast, invisible network, the power grid. It's the silent force that keeps our world running. So reliable, we barely notice it until it's gone. With a flick of a switch, we summon light, power machines, and connect to the world. But electricity doesn't just appear, it travels an incredible journey to reach us. Beneath our feet and above our heads, a web of wires and transformers links cities to distant power plants. This network is one of humanity's greatest achievements, powering everything from hospitals to handheld devices. We only notice the grid when it fails, but understanding it reveals the foundation of modern life. Join us as we explore the heart of what makes our world work. Power lines crisscross our neighborhoods, blending into the scenery, yet they're the final link in a colossal chain. These wires deliver energy from distant generators straight to your home, powering your daily life. Beyond our streets, massive transmission towers carry high-voltage electricity across vast distances, superhighways connecting remote power plants to bustling cities. Substations act as interchanges, stepping voltage up or down and directing the flow of power with precision. Every time you plug in a device, you tap into this immense, interconnected system. Engineers and line workers work tirelessly, ensuring the grid runs smoothly, even in storms. It's a hidden partnership, an unspoken trust that keeps our world illuminated. The grid's quiet reliability is the backbone of our modern lives. All this energy starts in one place, the power plant, the beating heart of the grid. Power plants come in many forms: nuclear, coal, hydroelectric, solar, and wind, each harnessing nature's forces to generate electricity. The principle is simple: make something spin. Whether it's steam, water, or wind, the goal is to turn a turbine. This spinning turbine converts raw energy into electricity, thanks to human ingenuity. Power plants are conversion engines, transforming fuel, water, or wind into electrical energy. Inside, engineers monitor complex systems, ensuring everything runs in harmony. Their work delivers the steady, reliable power our world demands. The journey of electricity begins here, at the source of our modern civilization. At the core of every major power plant is the turbine, a giant, spinning marvel. Steam, water, or wind pushes against blades, spinning a shaft at incredible speeds. In coal, gas, and nuclear plants, steam drives the turbine. In hydro plants, it's rushing water in wind farms. It's the breeze. The spinning shaft connects to a generator, where magnets and coils create electricity through electromagnetic induction. This elegant process turns mechanical motion into a powerful, invisible force. Whether by boiling water or channeling a river, the goal is always the same: spin the shaft, generate power. The turbine's dance is the heartbeat of electricity production. From here, the energy is ready for its journey across the grid. Once generated, electricity must travel far, so it's sent to a step-up transformer, boosting its voltage for efficient long-distance travel. These massive machines prepare power for the energy superhighway, minimizing loss as it moves through transmission lines. The electricity flows into a switchyard where operators direct its path onto the national grid. Here, power from countless plants merges, forming a vast, interconnected river of energy. With a click and a hum, the current surges into high-voltage lines stretching across the landscape. The first leg of its journey is complete now. It travels through wires and substations toward your home. The grid's orchestration ensures energy arrives safely, reliably, and almost invisibly. This is how the invisible force powers our world every second, every day. Once electricity leaves the power plant, it travels on an energy superhighway. This network of high-voltage transmission lines are the thickest cables in the system, designed to move massive amounts of electrical energy efficiently over long distances. High-voltage transmission minimizes energy loss by stepping up the voltage, allowing power plants to efficiently supply electricity over long distances. These lines form an interconnected web, a national grid, providing resilience and flexibility. Power can be redirected to prevent blackouts. The journey is fast, occurring at nearly the speed of light, allowing the grid to respond in real time to fluctuating demands. This makes a continental-scale power system possible. After traveling across the country, electricity nears towns and cities. It must pass through a transmission substation, the off-ramps of the energy highway. Here, large step-down transformers reduce the high voltage to a manageable level for distribution. Substations act as distribution hubs, breaking down bulk power into localized streams. Substations are critical control points, filled with protective equipment like circuit breakers. These prevent cascading failures. It is a nexus of safety. ensuring immense power is managed responsibly. The energy is getting closer to its final destination. Each step tames the raw power, making it safer for our everyday lives. The last leg of electricity's journey is often called the final mile. Having been stepped down at the large transmission substation, the power flows to smaller, neighborhood-level distribution substations. You have probably seen these, modest, fenced-in enclosures tucked away. These local substations perform another vital step-down function, reducing voltage for neighborhood distribution. This power flows through overhead wires you see running along residential streets, supported by utility poles. These are the primary distribution lines, the workhorses of the local grid, forming a complex network. Smaller secondary lines branch off to serve individual homes and businesses. A pole-mounted distribution transformer takes the voltage from the local line and steps it down to the standard voltage used by household appliances. From this transformer, the service drop runs to your house and connects to your electrical meter. From there, the wires enter your home's main electrical panel. At this point, the incredible journey of electricity is finally complete. It now stands ready to bring your home to life. The moment your day begins, you are already interacting with the power grid. That gentle chime from your alarm clock is powered by a steady trickle of electricity that has been flowing all night. You flip a switch, and the room is instantly filled with light. This simple act connects you to a continental network of power generation and distribution. You stumble into the kitchen, and the silent work of the grid is everywhere. The refrigerator hums quietly, keeping your milk cold. You press a button on the coffee maker, and within minutes, heating coils glow red hot. You drop a slice of bread into the toaster, again thanks to that reliable flow of electrons. Each of these appliances is a small but constant drain on the power grid, a demand that, when multiplied by millions of households, creates a massive surge in energy consumption every single morning. We are utterly dependent on this invisible force from the second we wake up. The grid must respond in perfect unison. Engineers watch their monitors as the demand curve begins its steep morning climb. Your simple act of making toast is part of a massive, synchronized daily event. The grid is a reflection of our collective habits, ensuring the power is always there for your first cup of coffee. Once you step out your front door, your reliance on the power grid does not diminish. It simply changes form. The world of work, commerce, and industry is even more power-hungry than our homes. Think of the office building where you work. Its lights, computers, printers, and servers all run on electricity. The elevators that whisk you to the 20th floor are powered by powerful electric motors. The climate control system that keeps the building comfortable, whether through heating or air conditioning, is one of the largest consumers of energy. A modern office is a complex ecosystem of technology, and electricity is the air it breathes. Without it, business would grind to a halt. This dependency extends to every corner of our economy. The grocery store where you buy your food relies on a constant power supply for its refrigerators, freezers, cash registers, and lighting. A single power outage could result in thousands of dollars of spoiled food. Manufacturing plants use colossal amounts of electricity to operate assembly lines, run heavy machinery, and power industrial robots that build everything from cars to smartphones. Even farming, once a symbol of manual labor, is now highly electrified, with automated irrigation systems, milking machines, and GPS-guided tractors, all depending on a reliable source of power to function efficiently. Consider the data centers that form the backbone of our digital world. These vast, anonymous buildings house tens of thousands of computer servers that store our emails, host our websites, and power our social media feeds. They are monumental consumers of electricity, not only to run the servers themselves, but also to power massive cooling systems that prevent the equipment from overheating. Every time you stream a video, conduct an online search, or make a digital payment, you are sending a request to one of these data centers, creating a tiny but tangible demand on the power grid. The digital economy is, in essence, built upon a foundation of electricity. The entire transportation network is also deeply enmeshed with the grid. Traffic lights that manage the flow of vehicles, railway signals that keep trains running safely, and the lighting and subway tunnels are all critical electrical systems. Airports need vast amounts of power for runway lights, navigation systems, and terminal operations. And with the rise of electric vehicles, our transportation and power infrastructures are becoming even more directly linked. The unseen engine of commerce is, in fact, the electrical grid, silently and reliably powering every transaction, every product made, and every service rendered in our modern society. The power grid connects us, Global communication happens at the speed of light because of electricity. The smartphone in your pocket is useless without the ability to charge. Its true power comes from its connection to a global network requiring a constant supply of electricity. Every message is propelled by energy flowing through the grid. The internet is a creature of electricity. Powering servers consumes a significant fraction of the world's energy. Without the grid, the internet would vanish. Our connected world is a powered world. Live news appears on our screens in real time. The grid is the silent partner in nearly every great human endeavor. The power grid has woven a new fabric for human society. It moves ideas and human connection across the planet. The power grid operates on a knife's edge, a system in constant delicate balance. Electricity generated must match consumption. Demand exceeding supply can cause blackouts. Supply exceeding demand can damage equipment. This equilibrium is both the grid's strength and vulnerability. This balance is constantly threatened by demand spikes. Power plants must quickly provide extra electricity. Failure can lead to rolling blackouts. Excess energy can be dangerous, sometimes requiring renewable energy curtailment. Better energy storage is needed. The grid is vulnerable to unexpected shocks. A single failure can trigger a cascade, leading to massive blackouts. The power grid remains profoundly vulnerable to the raw and unpredictable power of the natural world. Its infrastructure is constantly at the mercy of the weather. Hurricanes can topple towers, ice storms can snap power lines, cutting off electricity. From tornadoes to floods, the grid stretches across vast landscapes exposed to nature. Wildfires pose another severe threat, destroying infrastructure. Utility companies intentionally de-energize lines during dangerous weather, leaving customers in the dark to prevent disaster. Extreme heat causes lines to sag, while cold snaps freeze equipment. Flooding can cause short circuits and catastrophic damage to substations. Hardening the grid against nature's fury is an urgent challenge. The power grid faces a slow-moving crisis, aging. Much of the core infrastructure was built in the mid-20th century. Transformers, circuit breakers, and transmission lines are operating past their intended lifespans. Insulators become brittle, metal corrodes, and mechanical parts fail, increasing the risk of outages. This outdated infrastructure was designed for large, centralized power plants. Today's grid manages a two-way flow of electricity from renewable sources. The old controls are ill-equipped to handle the dynamic energy landscape. Upgrading this equipment is costly. Utilities often patch problems rather than overhauling systems. This increases the risk of blackouts. It struggles to incorporate clean energy and is vulnerable to attacks and extreme weather. Without investment in modernization, we risk the foundation of our modern society. In response to the challenges of an aging system, a new vision is emerging: the smart grid. It's a fundamental reimagining of how we produce, distribute, and consume electricity. The old grid was a one-way street. The smart grid, by contrast, is a dynamic, two-way communication network. It overlays existing power lines with digital technology and sensors, allowing real-time monitoring and management. A key component is the smart meter, a digital gateway between your home and the utility company. It reports your electricity usage in near real time, giving you insight into how and when you use energy. This gives grid operators a level of visibility they have never had before. They can pinpoint outages instantly and dispatch repair crews more quickly, dramatically reducing restoration times. This creates a more resilient and self-healing grid. The smart grid allows the grid to react dynamically to changing conditions and seamlessly integrate new technologies. It transforms our aging infrastructure into a flexible, efficient, and robust platform ready to meet future energy demands. The smart grid is the essential backbone for a cleaner, more sustainable energy future. A key challenge with renewables like wind and solar is intermittency. Smart grids use forecasting and real-time data to balance renewable output with other sources. Large-scale energy storage is crucial. Giant batteries act as a buffer, storing excess power. Microgrids, small self-contained power systems, enhance resilience. During blackouts, they can disconnect and continue to provide power. This creates resilience, ensuring critical facilities operate during extreme weather. These innovations pave the way for a decentralized, decarbonized energy system. Power becomes cleaner, smarter, localized, and resilient, empowering communities. The power grid is the invisible architecture of modern civilization. It faces strains of age and extreme weather. Its future is our future. We are building a system that is not only stronger, but smarter, capable of managing renewable energy. We're creating a more resilient grid with localized microgrids. This new grid will embrace the power of the sun and wind. It is about moving from being passive consumers to active participants. By embracing technologies like smart meters and electric vehicles, we can each play a role. The story of the power grid is ultimately a story of connection. By building a smarter, greener grid, we are ensuring that our lights stay on. We are building a brighter, more sustainable tomorrow.